Hey, guys. Well, it's not 8 o'clock yet, so, just hang around here and wait for the rest of the guys to show up. Meanwhile, we're just going to keep it all informal. So, feel free to chat. Feel free to ask any questions if you have. Well, hopefully questions that will, if you have questions that will be useful for everyone, just wait until everybody joins us, right? Because I think some people are late. And by the way, try not to use the chat. Try to speak up as much as possible for two reasons, okay? The first is the chat doesn't get recorded in the YouTube that we post, right? So if you happen to share something really worthy in the chat, it's basically gone after the class, and so future students won't be able to see it. The other reason is because I don't see it. I mean, and most of you don't see it. How can you be looking at someone's face or something else and reading at the same time? I can't do it anyway, right? Unless I keep, well, I think no. If I had a strip of the chat window on the side, it might work for me, I guess, because I can see, something's come up. I can read it, but I don't want to do that because I'm not doing this lecture on a big ass screen, right? I only have a MacBook Air, so I don't want to, lose out on the real estate side. I'd rather look at your pretty faces than the chat window. Okay, so don't type into the chat as much as possible. Just talk. I'm talking, and you don't have to worry about anything. Okay, so I think the way we'll run this class is basically just keep everything very friendly. And the online the Reddit forums are just going to be the same also. Informal, open and friendly. Nobody's afraid to share anything, okay? And the reason it's that way is because I think yeah, in the beginning I think when people used to ask questions, some of the students, maybe not even students, other people who were questioning, right, used to come back with smart aleck answers, and which kind of solved the problem for the people that were posted the question, but also made them feel kind of bad. So I started to delete those posts. And then miraculously, everybody just is like super helpful on the forums. If you look at the Reddit, right? So I sometimes I compare it. I compare the question and answers we have on our Reddit to some of the threads I see on Stack Overflow and some of these other public forums. And you'll be surprised at some of these other public forums because they don't have the bandwidth, right? Because they don't have one person in charge, like Wikipedia, right? So Wikipedia, there's one person that says, okay, I'm the benevolent dictator. You guys can all take little bits of it and manage your little pieces, but I got to make sure that you're all in line. Okay, so not in line meaning obedient, but not do something to shoot yourselves in the foot. That's essentially what he's saying. And so that's not there, and I don't think in some of these other forums. So Reddit, even though it doesn't have a single person managing the entire Reddit, seems to be working okay because these subreddits each have their own moderators, right? Although I don't know why that kind of thing isn't happening on Facebook, because Facebook has some moderated channels, but still there's so much nonsense that you see that it's not worth following most of those groups, I think. But Reddit seems to be striking a fine balance. That's why I picked Reddit, because previously I don't know. Actually, Agnes was in my class a long time ago. Agnes, you were in my class, right? Java class.
Yeah, your Java class.
Yeah. And I think we used Canvas for our discussion forum that time.
Yeah, I came back and you're like, we're using Reddit, and I was like, we have evolved.
Yeah, and I think I was really not happy with the Canvas forums because, I don't know what the rationale is behind the design of a discussion forum like Canvas, which is just meant to be ephemeral, like 1 quarter. Because is that based on the assumption that students will not say something clever, right? because many times I noticed around the time, right, a couple of quarters after Agnes left, I think, I started noticing that there were lots of really worthy statements being made by students, right? Incredibly insightful observations, and they're being stuck in a Canvas forum in response to someone else's question. And in fact, some of these answers are really helpful enough to be showcased in public as this is the way you should respond to someone asking a question, right? Doesn't matter if the question and answer are known to a person who's reading your public post. There is a meta message in there saying, this is the way you should answer someone's question, right? They may be a noob, but how do you know? You were a noob once too, right? So you might have forgotten. So that's the way you answer. And so so some of these answers and questions I actually read more than once because I enjoyed reading them. It's better than watching a routine sitcom, I guess, right? So and I thought it's a real pity that this is going away at the end of the quarter, and there's no way for me to import these, and it's a terrible, great amount of effort. So that's why I said, that's not the right way to conduct discussion forums. Let's move it all to Reddit so that it's all preserved for eternity, so that you can, come back to it 10 years from now and look at what you've said. And you can also do some, homework to make sure that your answer is something that you'd be proud of, right? And put it there, and then you can use it in your portfolio, right? In your resume. Oh, you don't even have to do that, right? Because these days the technology is so advanced that when before even recruiters reach out to you, they've got AI bots looking for information. They'll find out all the interesting bits about you, right? And it'll be spotlighted in a little portfolio that's presented to them, automatically stitched together, right? And you can write that, and so the head recruiter will look at it and that's the person, and says, look at that, he or she answered all these beautiful questions, and and they have these insights. Right, all of that is gone if you do it in a public private forum. Okay, all right. So is that enough rambling on? Well, I still have about 4 minutes of rambling on, really. I try to give students about 10 minutes, but I think we should probably start cutting down on it. Start diving into our classes sooner, starting next class. Because if you look at all the recorded lectures from last quarter, I think I think 3 quarters worth of recordings I have so far. And it seems like we typically spend the first 10 minutes talking, right? Talking nonsense generally, right? Not diving into the subject yet, waiting for all the other students to join. And I don't know if it really helped, because now the students started to get used to that and say, okay, class is not starting until 8:10, right? And so everybody started coming at 8:10. And so if you look at the videos, it's actually quite fun, some of these things. How and also I know I had a squirrel called Peter that used to make an appearance around that time, but now I built a little shelf for him up there, so he's not in camera range. But that was fun too. He used to come by in the camera once in a while. Anyway, so yeah, we have a couple of minutes. Here's the format of today's class, okay? I am not planning to go into the details of explaining data representation, because I've done that many times in the first 3 quarters recorded on video. Instead, what we'll do is just use the first week, that's today and Thursday, to just answer any questions you may have after having read through it, after having thought through it. And you would say, hey, this is something I want to work out. Can we work this out together? That's a fantastic idea, right? Because then you'll get the equivalent opportunity of coding on screen. This is also coding on screen. You get to share your screen or your iPad, especially if you have an iPad with a pencil or something like that, a tablet with a pencil. You share that, and then we can work through it, right? It's just a math problem and arithmetic problem, right? So we'll work through it together, step by step. Every time you get stuck, one of you or I, after a couple of seconds, we'll basically just feed nuggets of information to keep the forward momentum, right? So you'll find it's actually very nice and entertaining, interesting, really. Ask any of the students who have been driving, right? So driving in the driver's seat. In the driver's seat means you don't always get a chance, right? I'm the only one who always gets a chance, because I'm most of the time I'm just starting the car and giving over the steering wheel to you guys, and then you guys can pass it around. But even that time, I think we can minimize going forward, right? So in fact, let's try and do some experiments towards the middle of the quarter, maybe not too early. We'll see how it goes. What I'd like is for me to just join you guys as a student, right? Starting from week 7 or 8, something, right? Something like that. Well, not like a total newbie student, right? Yes, I'll be like a, I'll be like a knowledgeable student, right? So in other words, I'm not going to keep butting in, but I'd like some of you to volunteer. Take some time to master a particular topic, not master, right? Enough to talk about in class, and then, and come, and then you can pose a problem that maybe even you don't know the answer to, and say, let's all work on it together, right? So, and then we try and work on it together, and I'll also be participating like one of you. And I think it'll be great fun. It'll be a good experiment to try anyway, right? Because otherwise these YouTube videos will get repetitive, right? And students won't have a chance. Future students will say, hey, pick any quarter, it's exactly the same. So we'll try and keep things full of variety and fun. All right. Yeah. So as far as today goes, I'm happy to answer any questions you may have about the course, about how this class runs, participation, coding, what you can get out of this class, okay? I don't know. So here, right, there's always a finite proportion, not 100%, not a 0%, right? Somewhere between of people who just want the grade, right? Not even grades. There's some people who just want to pass, right? So you want to know what C++ is to pass, right? So CS2A, this is a significant number of those, right? And then there's some more who say, well, I don't want to pass, I want to get a decent grade, but this is not the center of my life, because I want to know enough to know that eventually when I go and master in my true calling, which is, let's say, archaeology, right? I want to know if I can bring my knowledge of computer science to bear on my, what I might discover in the ruins of Ireland. Right? Okay. So of course, interestingly, I actually knew a person who did that, right? Stonehenge, right? Who actually modeled the Stonehenge thing, and it's very interesting. I don't know, where is Stonehenge? Is it in Ireland? Somewhere in the Celtic Highlands, I guess. I don't know, right? Okay. So this guy was Australian. So yeah, so there's that part of you, and there's some of you who are saying to yourselves, you know what? There's a lot of stuff out there that is being done with computers, and it's so mystifying and magical. I want to try and do that too, right? And so you want to try, and you already have a vision of something that you want to build. Maybe that's not what you're going to build, right? So 90% of the time, people start out with a grandiose idea, and it's very important, right? Whether the idea is feasible or not, it's very important to have that idea. Say, I'm going to build the next spaceship to take us to Uranus, right, or Pluto or beyond, right? Doesn't matter. Just start, okay? Because at some point you'll find that the idea you started with was too grandiose, not even realistic. But damn it, I've spent so much effort already, right? So let's see what I can do with that. And then you'll say, okay, let me try and repurpose that. And then, you'll realize that at some point. And then when you repurpose that, you have all that momentum just being directed suddenly towards something that is feasible. And bam, you get a miraculous achievement, right? So I think that's why it's very important to just get started. And get started. Anyway, so some of you have seen that, you have a vision, and you're saying, I'm going to try that, okay? And you will actually see, right? This is being recorded, okay? So you can actually play this back, okay? In some years. And so you will actually see that you will be so glad to know this incredibly powerful tool, right? Called C++. Because with C++ and computer science and computer, the knowledge, you actually don't need anything else, right, to get what you want. You can do anything you want just sitting in one place in a Starbucks corner, okay? You can basically, rule the world, essentially. So, but that is a power. And you'll see each step leading you to that, right? And it's very fulfilling if you are able to see those steps. And I think there's a very high chance that if you stick through 2A, 2B, and 2C in this track, right, by the time you complete 2C, you will be solving problems that are really, really hard, that even, right? So some of you may have role models who are working in these big companies, right? The FANG companies, Google, Netflix, and so on and so forth. And they may be role models to you. But by the time you complete 2C, you will be solving some problems so that even they might find challenging. Okay, right? So and you'll be really glad. And also the other reason I think that recently I'm coming to believe that knowing C++ is a definite advantage in being given juicy opportunities to code by other people, right? Which really also translates to employment in a way, right? So because if someone says, that person, I'd like that person to work on this project, and this is a really juicy project, what are the chances they pick you to do that, right? Because there are not, there's a lot of juicy projects, but there's some that you'd really like to work on, and why do I say that? Why do I think that C++ is as opposed to there's so many other powerful and baby languages, right? Baby languages like Python and JavaScript. Now, when I say baby languages, it kind of sounds disparaging, right? This is kind of no. That's why I didn't. That's why I was hesitant. I was trying to think of a better word. What I mean by baby language is that it is a language that even a baby can pick up, right? Meaning that you don't have to be very advanced to be able to craft something that does something sensible in Python, right? So or JavaScript, right? So I can teach my nine-year-old nephew or niece how to write a confirmation dialogue in JavaScript on a browser window, right? And she might just basically type it in and hit return and say, bam, whoa, hello, right? And right, so so there's lots of these little things you can accomplish, and that's why I call them baby. But however, that doesn't make someone a programmer. Now, I think that is the important distinction, and I think what happens, or what I've seen, and maybe I'm wrong, is that there's a far greater number of people who think they are programmers because they can do something in a baby language, right? Because they can do something in JavaScript and Python, right? So let's not say baby language, JavaScript and Python, which are easy and powerful languages, meaning that they cover you can do all of the things most of the things, right? Not all, right? You can do most of the things you can do in C++, you can also do in Python, right? And people are using Python to do incredibly sophisticated stuff, right? So with NumPy and machine learning libraries like interfacing Sage and things like that. So and maybe all the person knows is to just issue a REST API call to a Sage interface, right? And have it deliver machine learning decisions on data, right? And but that doesn't make them a machine learning programmer or a data scientist. But they could say, well, I know how to drive Sage, I know how to do this, I know how to run machine learning packages, and therefore I'm a machine learning right? So that is why, however, you can do that in Python. I think that is the thing, right? And so I find that the circle, the set of programmers who know C++ has a higher ratio of those who truly know computer science, right? As opposed to those who just know enough to write a hello world and call themselves programmers. So what I mean by that is that if you say you know C++, it's not that you just learned how to code on your own, yeah, you'll get the idea. Maybe I'll phrase it better in my next quarter lecture. But I think that is the reason why knowing C++ really helps, because it kind of nudges you to go that last mile and really connect with the computer. Right? So you need to connect with the computer, not just learn its superficial features, right? So not just learning how someone behaves, but know how they feel, right? And I think that is more important to make a true connection and start appreciating rather than just using, right? So because when you use, you can only get a certain amount of use out of it, right? But when you appreciate something, then that becomes of use to you without you consciously using it. And then that kind of use you find is far more fulfilling, right? Because so much more happens when you actually know what's going on inside of a program. And because you'll find out too, when you get to CS2C, is that you can get a program working, right? So you can meet the spec. You can meet the spec, you will find the read the spec, you'll meet it, and you'll know that, but you will not be happy, right? And that is so cool, because I've got a couple of quests that basically elicit that feeling. I think it's very hard to find problems that do that, because you'll end up, you can solve the problem, but you won't feel happy with the solution. All right, and striking that note is hard, because once you feel that, that means you're starting to connect with the computer, because you know that you are doing the job, right? You're doing the job, but you're not doing it in the easiest way possible, right? Yeah, that is exactly, I think that's the feeling, right? Suppose someone told you to do something, and then you know how to do it easily, but or you know there's an easy way, but you still went the hard way and did it the hard way. And you say, well, if I'm going to do this again and again, I might as well learn the easy way to do it, right? And I think that is the feeling you'll get with some of these things, and it is really worthwhile, to know, because it gives you a feeling of independence. So because living in the Bay Area, you guys live in the Bay Area too, so you know a lot of non-computery people, right, who've done startups, and you know how many hundreds of thousands of dollars they spend, right, developing products, and they say, and so much back and forth, and they say, this is what I want, just sketch it out, and so on and so forth, send it back, and they do something and send it back and say, no, it doesn't work. And I know people who wasted millions of dollars this way, right, and eventually ended up with nothing at all, right, and all that money was wasted and written off. And I don't know where we're going with that. Yeah, right. See, and I think people may think that's it's an exaggeration, but it's not. And that is all of that money you can save if you actually knew how to do it yourself. Because you may think, I spent $1 million over 2 years interfacing with that company, right? So I lost $500,000 a year. Someone could say that, right? But if someone who actually knew computer science, no, you didn't lose $1 million over 2 years. You actually lost $1 million over 2 weeks, because what you got done over 2 years, that was, if you think about it, and if you actually track the development of a startup and follow the trajectory all the way through, it's very interesting, right? Because once you start looking, well, in the Bay Area and entrepreneurial world, you actually start looking at these things, right, and start looking at patterns. You'll see that this startup actually took 2 years to take off, but does it actually have 2 years worth of work that made it take off? No. What happened was that they did something, right, and then they got here. After 4 months, they did a pivot, right? And they changed strategies. And then so basically a fresh start, right? And then went so much more. Again, a fresh start. They reversed some changes and so on and so forth. So essentially what, the net effect they might have ended up with was 2 weeks of work, 2 weeks worth of work, which was basically distilled knowledge, right? From experience, bad experience, mostly bad learning experience that they've, so they're very valuable now because they've got distilled knowledge worth 2 weeks, right? But, they've suffered for 2 years. And what they've done is basically suffered with, sweat and money, a couple of hundred, millions of dollars, that amount of effort, which a student would basically put in learning C++, right? Because when you learn C++, work through some of these hard problems, many of the problems that these people went through, right, you would already have simulated in your head. Right, you would have seen, right? If we did this, this is what is going to happen. If we did this now, we'll see a win until now, because in our roadmap we have this other feature coming up here 3 months later. But if we do this now, even though we get a win for 3 months, that is going to totally, knock us, something like that, right? So you can see these things because, like a chess master, the more experience you get, the more you can play forward and think through. And the funny thing is, I found, and the reason I say this is because we actually did an experiment when I was in grad school, I think, what distinguishes experts from novices. And it was chess. It was done over chess. And experts think through a lot more moves, but they don't even know they think through these moves. Novices think through a lot more moves, apparently, a lot of moves, but they actually make it known, or they're aware of all the moves they think through, right? Experts not even aware, they think through them so fast. And so that's why it helps. In fact, I recently saw a YouTube video of an interview with a musician or a music teacher, and she was saying that even though she's such an expert musician, she would never ever perform a piece in public until she had practiced it after having ironed out all the creases, meaning no more stuttering and stammering anymore, right? You can hit all the notes. After that, she said, I still have to practice it 100 times on my own, right? A minimum before I can perform. And because they want to get it all into muscle memory so that their fingers can do the playing, or their throats can do the playing, and their minds can basically just do the enjoying, right? Because then when you start enjoying what you play, then your mind will also start directing it right towards more enjoyment. And I think that is the same feeling you'll get with C++ also. And I think many people who drop off, right, from a pursuit of learning C++ or things like that, is because they drop off before they get to that place where they can start extracting enjoyment from it, right? So I would like all of you, and I'm actually glad to see all of you here, and please do come every class and make sure that your camera is on, okay? Or you should be speaking, right? You can have it off, but you should also be speaking so that I know. Yeah, I don't. I would rather not have it. I would rather prefer the students not just logging into the lectures for the sake of it, meaning they just log in and just disappear, right? Yeah, well, I don't know. Fernando, okay, yeah, thumbs up is okay, but ideally, right, it should be like other students, right? Because we're all just friends here, and I don't, in the past, you can look at past lectures, right? I mean, people have also attended lectures, lying down in bed, right, with a phone like that and all. So nobody cares. All we care about is really, you can do that in your bed if you're going to be coding, right? We can have you live code on the bed, okay? Because that'll be too painful for other students to watch and participate. So I think if you're coding, you need to be in front of a computer, right? Everybody else, I don't care. Right, but you just have to be present and participate it, right? So, and you can talk about any damn thing, right? So you got to keep it slightly relevant, but sometimes you get a break like this, right? When you get a break like this, you can talk about anything, and then when it's time to get back into the subject, one of you or me will rein us back in, and then we'll start talking about it. All right, so I'm glad we're all here. As many of you as possible, please try and get your camera on. And let's try and start answering questions. Well, I don't have to be the only one, but I'll certainly try to answer every single question. But if you have questions, either to do with the class, course, C++, or data representation, right? We'll have the entire next class Thursday, right? And by the way, not Tuesday and Thursday. Tuesday and Thursday are the only two classes. But honestly, hey, are there any 2B students in the class today? You know what? I realized that not all of my 2A students went to do 2B. And by the way, Agnes, these two, today and Thursday, they're going to be exactly the same as what you heard back when you did Java, right? This data representation hasn't changed at all. It's exactly the same. So, all right. So, yeah, I don't know. I invited some 2B students to join our class, but I don't even know if the Zoom link will work.
Can I ask a question?
Yeah, sure. Lei, is that how you pronounce your name?
Yeah. What's the freeze date? What's the freeze date?
Oh, freeze date. Yeah. The freeze date is the date nominally when I copy the.
Oh, yeah. I know what it is. Like, when is it? Sorry, I should have asked.
Oh, when is it? Okay. All right. So since everybody's here, let's just make it the Monday of the week following that Sunday. How about that? Right? I think that's what it's been, and students have been happy with that so far. Okay, so it's not the Sunday night; it is the Monday, and generally, when I wake up, it's around, well, maybe not. Well, let's say 8 o'clock, right? So around 8 o'clock on Monday. So you have a bit of time. You don't even have to. Well, ideally, you shouldn't be working on Quest at all. By Saturday, you should be all wrapped up, basically just polishing it, right? Polishing things, eking out a few points here and there, maybe. I think that'll be okay.
Okay, so every Monday would be.
Yeah, not every Monday.
Oh.
Who has a syllabus?
There's just one freeze
There's only
date,
two
right?
Mondays, right? So there's
Like
only
the
2
first
Mondays
four.
that will be frozen. This is the freeze date.
Okay.
I think it is the Monday of week. This is the Monday of week 6. I think it's a Monday of week 6 and the Monday of week 12.
Okay, all right, thank you.
Oh, is it? No. Maybe it's 4 and 11. You got to check the syllabus, okay? It's
Okay.
one of those 2 things, right? It's either those 2 Mondays. Until then, you can class. Here's the biggest mistake most of the students in the past have made, okay? And don't make it. Please don't make it, because it's not worth it for you. Don't put things off. The first few quests are going to be so easy, and you'll think, okay, well, I don't have to do any of this now. I'll come back a few days before the free state, and I'll just zip through things, and you'll be totally screwed, right? Because it's only the first couple of quests that'll be easy, right? And it'll slowly start pushing you, because here's the truth, okay? Maybe in some other sections you may get by in CS2A, just get a grade or things like that without having to know things. There is a lot of stuff to cover. You have to know, according to the state even, right? So even the state agrees, which means, right? You have to know and be comfortable with the use of pointers, right? Pointers in C++, which is really the most unique and the distinguishing feature, right? The pointer concept of C++ is really everything. Everything is leading up to it. And we will discuss that in week 11. And unfortunately, many sections of CS equivalent to CS2A out there, right? They just ignore. Not ignore, it's in the syllabus and everything, right? But students won't make it to that point. And they'll not learn about pointers. And that's a total waste. Essentially, what that means is that I'm going to learn C++, but I'll only learn the Python. I'll only learn the Python or JavaScript aspects of C++, right? I won't learn the real C++, right? So really, you never learn C++. You came in with Python, you're just going out with Python. You just learned a slightly different syntactic sugar. That's it. Yes. So it's no point in doing that. So you have to learn about pointers. And so if you happen to have friends who are enrolled in sections where you progress until the point where you learn about pointers and linked lists, but you're not really going to implement them or try and understand them, it's the wrong C++ section, right? At least if you do that section and come to my CS2B, you'll fail, right? Because the very first lab in CS, very first quest requires a very detailed knowledge of pointers. You actually have to understand how pointers work, right? So, and we'll do all that in week 11 and 12. We'll actually do that in class. One of you, or many of you, right? 2 or 3 of you will be coding pointers on screen. We'll be coding links. We'll be, coding, nodes and saying, okay, that node points here. I'm going to disconnect that and point that here, there, here to there, and so on and so forth. All of that is going to be so much fun. You'll actually see that in action. You'll make changes, real hot tweaks, right, to data structures, and see those things happen. Where's the fun otherwise, right? Otherwise, it's just book knowledge, right? Otherwise, you're like reading something and forgetting. And so we got to get to that point. But in order to get to that point, we got to drive hard, okay? And which means that it's going to be totally worth it. I can promise you that it'll be totally worth it if you set yourself to it. But if you think that CS2A is going to be one of 5 other courses that I'm going to do, right? I got to focus on all of these things, and CS2A is on the side, right? It's icing on the something like that on the cake. It's just not going to cut it. It won't work. And so you do need to put yourself into the course and into its successors too. I think it will be totally worth it. You'll find that it is incredibly useful and worthwhile in your life, right? To give you lots of things that other people can have to spend a lot of money and frustration and time and effort getting. You can just do in your head and find out whether it's worth it or not. All of those things are valuable, and people don't put a value on those things, but you can actually translate those into a monetary value if you want, right? And say, well, if I hadn't done that, I would have had to spend the equivalent of so much, right? In order to get where I am, and even then I wouldn't be sure if that's what I wanted, right? I have to cut corners, make compromises. In fact, in CS2C, there's actually a quest for cutting corners, right? So there's going to be a quest in CS2C where, well, this is CS2A, in CS2A, 2C, where there's going to be a problem you can solve. But if you start cutting corners, on the way to it, you can cut corners here, here, here. But if you start cutting corners, you'll lose your way very quickly, right? If you don't cut corners, if you make sure that you traverse the whole path, you'll actually get to the solution. So all of those things are really cool, right? It's almost like it's like a game. I think I love making them anyway. So I hope all of you can get to it at some point and enjoy them and derive the full power of C++, the pleasure of C++. Okay. So are there any other questions? Yeah. Or you can also ask each other questions. Okay. So one of you can ask, and talk, and I'll just be silent and I'll listen, just like you guys are listening to me now. So that's fine with me. Or you can ask me questions.
Did anyone figure out what the spec is? I was a little confused about that.
Who asked the question, by the way?
Me, Neil.
Neil?
Yeah.
Oh, Neil here.
Well,
Yeah. Someone can feel free to answer, Neil, or you can try and find out the answer too. Your question was, what is a spec?
yeah.
Okay. Well, why doesn't someone share the screen? And then we'll just make sure that since everybody's here, can someone just pick up the screen and share it? And then we'll just, I can walk you through how to find the spec. Or someone can walk through how to find. Does anybody know how to find the spec of a quest? The specification, what do you have to do for a quest? How many of you have read the syllabus?
Oh. You just you enter the password and then
Yeah.
it'll tell you. Okay.
Yeah, there's a, never mind. Okay, yeah.
Just pick up the screen. Anybody who knows, just pick up the screen. And share your screen and open a web browser, right? So before you open a web browser, don't do it now. Make sure it's a private browser, so that if you accidentally happen to go to Gmail or something, and then your email shows up, and then the whole video becomes unusable, right? Or I have to spend like hours now pouring through the video to find where it is and cut it out. So please don't do that. Open a private window. Make sure that it doesn't have any history or nonsense, right? Okay. And then and go to your go to the Quest site, and then find the spec and download it. And here's how you get the spec. Okay, guys. Right. So what did you type? Hey, who is this, by the way? Oh, Neil.
Oh, yes, me.
Neil. So Neil typed quests.nonlinearmedia.org.
Yeah.
That's right. It's just a secure website. So and then well, if you and here's a mistake that a lot of students I see, in the log files, I see this mistake. If you type, I say start at Fangs, but the password for the first quest is actually a tiger named Fangs, not. So it just refresh the screen, Command R or Control R or Command R. Where you see that prompt, the watermark thing keeps changing, and it's a different quest. Right. See, tadpole dancing was the first quest for my, when I taught Amazon Cloud, that was my quest. Okay, my first quest. So that keeps changing. Every time you refresh, you get a different one. And in fact, if you the Legend of Fangs is not even computer science, right? It's a screenwriting thing, and you'll just get a screenplay or a drama or an audio play, right? So and lots of people go there, and because they see the word Fangs and they think that is the first quest to type in CS2A, and unfortunately, I have to resolve the confusion somehow. It's a bit of a bother changing these names at this point. So you have to type in a tiger named Fangs. That's the first quest. Okay. A tiger named Fangs. Yeah, it's just right. And if it's backspace one time.
Oh, okay.
Right, and you'll know if you got the right password. Go back and type the tiger name, and you got backspace. Oh, change it to change one character. Change any of the characters. Right, see, it's gone. Right, so if you got the right password, you'll know. As soon as you type the right password, the whole thing will become, a boldface or something. Some change will happen here, and you'll hear a sound, right? So you can put it back, and there you go. Right, so that's the correct password. and then you can click anywhere.
Okay. Yeah.
Yeah, but that's fine. You can click there too. Now you can. There's also, I think, is there a download button? There must be a download button here, right? No, there must be a download button right there. And click that. All right. So in here, can you right-click there? Maybe right-click on the PDF. Oh, you don't have an option to download the PDF? Oh, it actually says it. Actually, you're able to save it.
Oh yeah, I can save it.
Oh, actually, if you save it, it comes in as a PDF. Is this not Is this not Chrome?
No, I'm using Edge.
Oh, I see. Maybe the interface is different. Okay.
Yeah.
So yeah, so
Always.
in Chrome, you actually have a download icon. In the PDF up here on the bar, the plus and the minus and so on.
Okay.
You also have a download icon. And if you click that, it'll basically just download the PDF. Bam. But that's what Neil has just done now, right? So Neil, have you done it? Have you downloaded it? Saved it?
No.
Yeah, just save it.
Right.
Save it. Unfortunately, it'll save it as getspec.pdf. Save it as quest1.pdf or something, or you can rename it quest1.pdf, and then you can view that. That is your specification for the very first quest. This is what you have to do, and you can see that it's actually very, very straightforward, right? It's nothing at all. You just open up your IDE, and the whole idea with this quest is that you just get familiar with the questing interface, meaning that you get to the place where you have the hello world.cpp file, and make sure that it's not a text file ending with a .txt. No, it has to be hello world.cpp. And make sure you can see the extension, because in Windows, even in Mac, I think, right, the extension can be hidden, and you won't see everything in the file name. So you got to make sure that you got the right file name. You got to make sure the file inside the file is not UTF characters, all ASCII characters, because you can have UTF characters. You can program in 16-bit characters, and unfortunately, I'm not dealing with UTF characters on the compiler side. So you have to make sure it's ASCII plain text, just like a regular C++ program, meaning that you should be ready to be able to code with the bare minimum resources, right? This is like minimum entropy living. So meaning you don't need any sophisticated equipment, you don't need a rocket or even sophisticated computing to get your C++ program to run, because very basic C++ compilers you can just download to run even on your phone. I mean, how does you write it on the phone? Believe it or not, your phone, 90% of you today have a telephone which has more computing power than the computer on which you run the quests, right? So when you go, and in CS2A, the quests are very simple, so you may not see that it's all that. Thank you, Neil. Neil, thank you very much for volunteering to do that. So you may think that it's not all that complex, but very soon in 2B and 2C, you'll see some quests that require real juice, right? Solid computing, and number crunching and so on. And how can you and then you will be surprised to know, wow, all of that is happening on a computer, and my phone can do that and even more, right? Because your phone typically, until about a quarter ago, right now your quests are running on, I don't know, a machine with one CPU and maybe 2 gig of RAM, right? One CPU and 2 gig of RAM, one single core CPU, and I don't know, 2 gig of RAM. That's all. All of your quests, all of the quests from everybody worldwide, right? They're running on that one machine. Of course, I mean, if the load gets too much, it'll just clone itself into 2, right? It'll just keep doubling in size, but it hasn't doubled that many, right? Even when the load was really, really hard, which is like one day before the free stage, usually, right? Everybody's trying to quest at the same time. And then the questing server says, oh my gosh, I was asleep all this time and now everybody wants me. So I'm just going to split into like 5 copies of myself, bam, like that. But even then, I've only seen like two copies at most, even on the most intense days, even when people from other countries were questing. So so your phone has a lot of computing capacity. So what even if you didn't have that, I'm saying that we need to be able to get to the bare bones without a sophisticated IDE, without many tools, debuggers and so on, still be able to craft a program that can be translated into machine code and be able to run, and meaning that you don't need all that, right? And that's the C++ takes you very close to that place, meaning it's so close that you can actually see what's missing and whether you need it or not, or even fill it in on an as needed basis. You can say, I've written a C++ program which does everything, but for this part here, which interfaces with that very specific device that is built into rover on Mars, right? I need to write some code in the ARM programming assembler language, right? Machine code for that particular chip that lives on rover, right? That can be. So yeah, maybe you can write it in C++ and translate, but you say, I'm going to do it in that particular code because that's better. So very rare situations like that, But if you take a JavaScript programmer, for example, right? It's someone who says I'm a programmer because they know JavaScript and Python. But if you ask them, how does everything happen to the last mile, right? How does it happen? Because once you master C++, you'll know what happens right down to the level of the electrons, right? You'll know all the way right down to the. So when you see something happen on the screen, you'll know. So maybe there's 3 trillion electrons that danced in order to make something happen on the screen, right? So you may not know the details of every single dance, but if you know the details of C++, you will know exactly what dance each one did, right? So you can say, you can say on your phone, right? So you can say, that's exactly what is happening. Yeah. In fact, literally what's happening is that on your phone, it has a, let's say it has 1 gigabyte of memory on your phone. Actually, most phones today, how many gigs do they have? Like 128 gig, right? It's 100 times more memory. So even if it had 1 gigabyte of memory, right? 1 gigabyte is 1 billion transistors, 1 billion switches that can be turned on and off, right? 1 billion switches. Now imagine going into a football arena with 1 billion switches that you can turn on and off, right? Now you'll know, right? It's possible. But the beauty is that when some incredible thing happens, you will know exactly that switch number 400,729, okay, needs to be turned off, right? And so on. You'll know exactly what needs to go happen. You'll know the details of a dance. You'll know the details of a dance, and you can choreograph it perfectly, even though you don't have to perform every single piece of it. So you can basically fan it out. You can map reduce it, right? You can say, this is what needs to happen. All you guys go and make it happen, and you can see this beautiful screen play right in front of our eyes. And so that's happening, right? Because on your phone, when you receive a ting, right now, a ting, something happened. And in order to hear that ting, and you say, oh, wow, I just received an email message. In order to hear that ting, so many billions of transistors had to dance. And the beauty is that as a computer programmer, you have the power to that fine level of power, to tell a particular transistor of billions of transistors. You can say, only you have to raise your right hand. Everybody else stay quiet, right? And you can do that when there is an arena of billions of switches. You can do that to one, right? And the thing is, when you are an expert C++ programmer, even though you're not doing that on a daily basis, you're not going and doing these things, right? You're thinking at a high level, just like Python programmers or any other programmer. You're thinking at the level of the product, right? You're thinking in terms of beats and sounds and melodies and things like that. That's the level at which you're thinking, but you don't stop there like the rest of them, right? So you would say, well, this is what I need to happen, but in order for that to happen, these things need to happen, right? And in order for these things to happen, I need to be able to see all the way through to the bottom of the pond. So I need to just settle down and let the water be calm and clear first, so I can see the bottom. Okay, now I can see the bottom, so I can drop the anchor to a place that I want, right? And then I can slowly navigate exactly to the place that I want. So you'd be able to see that, and the advantage of doing that is that many times we plan things in our lives, right? And we find things going awry. Yes, because very few things happen exactly as we plan. There's things, deviations, right? Now, if you can see clearly all the way through, you will not have any stress, because, right? And you can test it out on your own, right? And tell me, or or decide for yourself whether I'm true or not, right? Or correct or not. And I think if you can see clearly, you don't have stress. People who are stressed out cannot see clearly, right? And the reason for that is that if you cannot see clearly, you get a lot of anxiety, because you don't know, right? Something could go wrong. What would happen if that goes wrong, right? Oh my gosh, I got to be prepared for that, right? You go and do that, but it's never going to go wrong. If you could see clearly, you know that's never going to happen. So why do you waste 90% of your life trying to solve a problem that is never going to happen? That's because you couldn't see clearly, right? So I think that clear sight just basically gives you peace of mind, right? It says, I don't have anxiety because I can just see clearly all the way through. And so if you master a field, you can build, monuments in that field without stress, because anxiety and stress and fear are the things that keep people away from greatness. right? Because, you know, everybody starts out with a grandiose goal, you know, I'm going to do this, I'm going to, you know, and so I'm going to conquer the Milky Way, right? Right? And do that. But at some point, we get intimidated and turn back and say, you know, I don't know what's going to happen, you know, right? And so that we had a grand goal, but we gave up because of fear, anxiety, and right, and self-doubt. And the way to remove that is just to develop the knowledge and say, I'm just going to see all the way through. Well, I don't have to go all the way through, but I can see, right? I'll see and keep on refining my vision so I can see, so that when I eventually start moving in the direction, I won't have stress, right? Because if I don't have stress, I'm free, right? If you have stress, you're not free. You're not a free person. Even though you may go all the way to the Mars and Moon, and you conquer the whole universe, you're not a free person. You're beholden, right? Because you're afraid to say things. You can't speak your mind, right? So you are a slave, and so you cannot be yourself. And but having total knowledge will basically free yourself. And when you're free, you can basically say what you want. Because, you know, if things go wrong, I'll say, well, okay, well, that was wrong. I should have done that. Maybe I'll do that, right? I won't waste too much effort going the wrong way, right? But if you're stressed out, I think what happens is that, and I've seen that in students in the past, when they get stressed out, they'll throw more good money after bad. I don't know if you've heard the phrase, but it's very common in England, throwing good money after bad. Meaning that, you know, I think I read it in some English books. And I say it's a phrase that I actually like, is because when the railroads were very popular, right, in England, people were making a lot of money on rails. They had lots and lots of these schemes, right, fairy tale schemes of get rich quick, and that you can buy shares in, guaranteed to appreciate 1,000% in a year and things like that. So people would buy shares, but then the truth about these companies starts coming out, like the tulips in Holland, right? And people start selling, and the price starts going down and fluctuating and so on and so forth. But you know, it's bad, right? It's bad, but people use good money to buy it, but they knew it's bad now because the truth is starting to come out. And prices started to plummet, right? How many of you have actually had this experience in the stock market, right? So I've had this experience in the stock market when you're playing with play money in the long distant past. But you know, you buy some stock at a price thinking it's going to go up, but it actually went down. And then you did some research and found out the reason why it went down is because the company was crappy. The CEOs were basically embezzling money. They were going on cruises when their employees, programmers were slaving away, and right. And so that's not a company I should be investing in. I should sell my shares. But instead you say, well, you know what? I believed in that company. So there's a lot of other fools who probably still believe in that company. So let me get my money back. And so I'll buy more money at that cheap price, more of these shares at that cheap price, so that when it starts coming up even just a little bit more, I'll sell it, right? I'll at least recoup my money. So they buy more shares. So that experience or that behavior is called throwing good money after bad. Does that make sense? Because what happens is that this is not going to get better, right? It's got a bad CEO, bad company fundamentals. It's going to get even worse, right? You can't say it's got cheaper, so I'm going to buy more, right? So that is so. And I think that happens with students is that sometimes they try to, especially in computer science and programming, they spend a lot of effort chasing down a bug, right? Actually, I'm glad this is being recorded. Maybe you should come back to this and review this when you're stuck with a bug in 6 weeks, right? When you're working the more serious quests, because what happens is that many students will suspect that there is a bug in their program. The program doesn't behave as you want it to, right? And this is what you'll find. Many times we'll find, no matter how long you've been programming, right? If I write a program tomorrow and I say, oh, this is what's going to happen, you'll find it, right? Sometimes we'll start writing code in class and I'll be calling out code and you'll be typing and I'll say, okay, now let's run it. This is what's going to happen, right? And then the student runs it and something totally different happens, right? So yeah, I think that no matter how long you've been programming, we should be prepared for that surprise and that we haven't thought everything through. There's something that we missed. I don't know how we got started talking about that. Yeah. So when it comes, so what happens is that it behaves differently, right? And then the students, and then I ask students, right? I made sure to ask a couple of students not connected to each other and who don't have a chance to tell each other that I was asked, right? Why do you think that happened, right? And this person gave me a reason, which was a good reason, but also the wrong reason. A good reason, but a wrong reason. And that is a dangerous thing, right? So good but wrong is actually dangerous. Good meaning, it's good meaning, it makes superficial sense, right? That's why it's good. But it is wrong because it doesn't make deep sense. It's going to lead you down a rabbit hole, meaning that there is a problem and you've come up with an answer for it. It seems kind of okay, but if you pursue that solution, it's going to lead you down a rabbit hole of 2 weeks or even 2 days of wasted effort and frustration, saying, try this, didn't work, okay? And that's because, okay, well, it seemed okay. But so that is throwing good money after bad, because you identified a problem, but it was a bad, the bad solution. So by having a lot of experience, and unfortunately, and I maybe prove me wrong, hopefully, right? So I can pass this knowledge on to future students. I haven't found a better way of helping you identify the rabbit holes. Okay, other than there's only one way, and the only way is to fall down into many rabbit holes. Okay, you got to fall down these rabbit holes, be endlessly frustrated, right? And ask me for help, and I say, no way, get lost, right? And so you ask your friends for help and say, yeah, I solved it. You'll solve it too, right? Hey, go to the STEM center and say, okay, wait, try these concept problems first. Okay, you're going to be frustrated, and you're going to say, oh, damn, I shouldn't have taken the section of CS2A. I should have gone to maybe some easier section, or I shouldn't have done C++ at all. I should have just stuck with JavaScript or Python, or right? So you'll be frustrated, and I think that is the only way, unfortunately. But I think it is better to be frustrated when you have either you have caring parents around you, or you have a caring teacher near you. Okay, it's better to be frustrated then, right? Rather than if you say, I'm not going to be frustrated when there are caring people around me, then you haven't basically done away with the frustration, because you have frustration in the bank, you just haven't withdrawn it, right? It's there. You just say, I don't want it now, but you got to withdraw it at some point, right? It's like your karma, it's got to come. So at some point, when all these people who would have helped you, who cared about you, who would have helped you if you were down the rabbit hole, totally lost, right? And you were about to kill yourself, right? They're not there anymore. And that's the wrong time to be feeling the frustration. Yes? Okay, so this is the best time for you to get frustrated with C++, with programming, with computer science, right? You have to get frustrated, because only after you get frustrated, you can get to see past the frustration. Because the real beauty of anything, right? Not just computer science, any art, the real beauty lies after that initial hump. The initial hump is the frustration, right? Initially, it's going to be really fun as you're coming downhill, because every art, when you start off, it's really easy initially. That's why everybody says, as soon as they start doing ceramics, they say, I'm going to be a great potter. When it says painting, I'm going to be a great painter, right? Because, the initial things are easy. You can write the hello world very easily, right? But then, so that gives us a rush, because it makes us feel good about ourselves, in the wrong way. Because it says, oh, you must be really good because you learned something really fast. You were actually able to do something that did something, right? and that happened. And that gives a rush and adrenaline, and makes us feel. And if you've experienced that enough, and you have become inured to that sensation, and say, well, I've had that rush so many times, but always it dies off, right? After some point, it gets challenging. No matter what field I pick, right? Whether it's acting or singing or music or piano or computer science or C++, right? Mathematics, doesn't matter. Initially, I get a rush, right? And at the very beginning. And then it kind of peters out, and it starts feeling hard, right? And that is a point at which many people give up, right? And say, maybe that is not for me. Maybe I'm not a mathematician. Maybe I should go to acting, right? Maybe I'm not an actor now. So 1 year here, 1 year here, 1 year here, and pretty soon you're like 25 years old, and you say you've examined so many different kinds of things without really sticking to it. But the issue is that every one of those has a golden field, but it's all hidden by that hill, right? So you got to get over, and you got to stick through, right? And I can promise you that on the other side of the programming valley, there's a really lush green pasture that is so beautiful. And the reason I always keep recommending computer science and C++ essentially, because C++ is any language really. But C++ is good, right? Because when you know C++, when you tell someone you know C++, it tells them that the ratio of the Bayesian probability of you knowing computer science really, as opposed to just knowing programming. Let's say that, yeah, I think let's make that distinction. We're actually coming back to the point I was trying to make then, right? Python programmers versus C++. Both camps have brilliant people. Equal. I know Java programmers and Python programmers only who refuse to learn C++, who are really absolutely brilliant people, right? But they had their reasons, solid reasons, but they also knew computer science. So the brilliant people exist in both camps, but I think they are far more diluted in the non-C++ camp. So if you take the circle of only C++ programmers, the ratio of people who really know computer science is much higher inside the C++ circle than inside the whole Python circle, because Python is so easy to learn, right? JavaScript is so easy to learn. There's more people who claim to know these languages than the ones that really know, right? So because those people learned enough of the language to climb up the hill, maybe 100 meters, 200 meters, but they decided to set up camp there and live, right? But the people who really know computer science, right? They didn't stop here at Python or JavaScript. They knew, oh, I could do this in Python, but how do you do that in Python, right? So they learn more about Python. They learn, and they end up going to the other side of the hill where they'll also meet, C++ programming and all these other people, right? So that is why I think knowing C++ puts you at an edge. And also it opens up a lot more tools for you, right? There are a lot more tools that you can do more fancy and fun stuff with. Even graphics and other languages, even high-level visual languages, right? Eventually, they all get translated back into assembly code through some form of C++, I think. I don't know. I think even Unreal does that, maybe.
Can I make a comment, Anand?
Hmm?
Hey, this is Agnes. Can I make a quick comment about
Yeah,
everything you just said? So I haven't seen the green hills and pastures yet, obviously, but I would like to keep it in mind, of course, as the class and the
You
series
need
goes
someone to
on.
push you through, right? That's for me. That was what I felt was most important for me, is someone to just push me, because there are so many times I was just ready to give up in many things.
Yeah.
And sometimes it doesn't make any sense, and it just needs a parent or someone to say, doesn't matter, right? Don't do it for me, right? You have to do it for me, or something like that, right? And you have to push someone over. And here I can basically hold you responsible. I have the grade. If that's important to you, I can push you guys.
But I think it would be really great, like, from your years of experience and such, if you could maybe talk about, because I've been sort of like, in and around the industry for a while, and we don't, like, in classes, we don't hear about, stacks that's used for development. How does, like, a language play into, like, the greater, development life cycle, or something like this?
It's good you're doing C++, because we have an entire lecture devoted to exactly that.
Right? Yeah. No, I'm sure it's coming, but just to help me and maybe some of my classmates, like, keep the green pastures and hills in mind. It would be great if we can hear more about, like, oh, how is it used in the real world, or, like, how does it play into the stacks, and all these things.
You guys should help me then, because remind me.
I'll pop in
every 5 minutes, right? So you can ask me every 5 minutes if you want. How is this used in the real world? I'm happy to say something on that front, as long as but ask me anytime, right? If you feel that we're getting detached from reality, just ask me.
So I have a comment. Actually, so YouTube backend used to be written in Python, and they did this huge project to migrate to C++.
Hey, Alexandria, right? Alex or
Yeah.
Alexandria?
Alex.
Alex, you're cutting out. Is your audio connection okay? Because
sorry. It might not be okay. I'll fix it.
Now I can hear you. I think.
Oh, okay. Can you hear me?
I can hear you now. Yeah.
Okay. Yeah, I was just commenting. YouTube used to be written in Python, the backend, and they migrated to C++, and it was like a huge, like, 2-year-long project.
2 years sounds pretty short.
Oh, well, not with like 200 programmers.
Oh, yeah. Resources.
Yeah, you can. Yeah, in fact, with C++, you can write a number of custom C++ libraries for your Python modules, right? So you can write a Python module in C++ that people will find useful. I think NumPy was written in, I don't know, maybe. But you'll actually implement some of these algorithms in C++ yourself, right? In 2C, you will implement those algorithms. Then you'll know. Then you'll know. Those of you who've been using NumPy and other things in Python, you'll know. By the time you get to C, you'll know. Oh wow! You know, in Python, I've just been issuing these calls mindlessly. This is exactly what happens. You use dictionaries in Python and JavaScript, right? You use dictionaries. Dictionaries are basically, you know, indexed by arrays. Like I can ask, oh, how many points did Joshua get? How many points did Agnes get? And so on and so forth, or grade and so on. Mapping one to the other. That's a dictionary, right? What is the meaning of that word? What is the meaning of this word? It's a dictionary. And you use that in JavaScript, Python, and so on, right? Two arrays, curly braces. But you'll get to implement that. You'll implement that in the back end. And the reason I think it is important is that you'll get to know you'll get to know the cost of using these things. That is the real reason why someone needs to know computer science and programming. You know, it doesn't have to be C++. The reason you need to know C++, computer science, the proper programming, as opposed to being a self-taught programmer, is because if you're a self-taught programmer, you're going to be building products based on your knowledge of how you can use things, right? You may have two things that both do the same thing, but one may be horribly inefficient, but easy to use. One may be very efficient, but hard to use, slightly harder to use, right? But if you are just a Python programmer, you'll pick the one that's easy to use, right? But you won't know, you won't appreciate the efficiencies involved or the magnitude of the differences. But if you know that, oh, wow, I should be using an array here instead of a dictionary, right? Or if I use an array instead of a dictionary, I'd get like a 10-fold win. And by investing a 1x effort, I get a 10x return. That is what, you know, knowing about programming, and because both people, to one person who says I'm a programmer, I can do these machine learning things in Python, I've been doing this for 10 years, you know, I've been working at XYZ, right? They do this thing, but in an inefficient way. But you come, you know, with your C++ knowledge or computer science knowledge and do it, you also do the same thing. And for most people, maybe a marketing-minded CEO, they may not even see the difference. Maybe they end up rewarding the person who did the bad job because they used fewer Python resources. But they don't know that in 1 year's time, when their traffic grows 3x, this solution won't handle it, and you have to spend 10x more time and effort to re-engineer it. So all those considerations will start playing out in your head. And the reason I think that knowing about these things is so important is because it just saves you a lot of money and time and effort, right? So because if you didn't know these things, you would have to do them physically. Right? People who can't do these things mentally will have to do them physically. So if you can simulate something in your head and say, wow, I mean, I want to do that, but if I do that, well, these are things that could happen. That could have, oh my gosh, that person could end up really, really disappointed, and I didn't want that to happen, right? Maybe you wouldn't even have seen that, right? If you weren't clever enough, you would not have seen that. And you would say, well, the only way to find out is to do it, right? And then the only way you find out is after investing the time and effort and energy, and also annoying that person who you may not have annoyed at all. And you did that because you were not clever enough to think through that, right? So I think that is why knowing this is really good. It saves you a lot of time and effort when other people are just basically grinding away, right? You see people working 9 to 5 at hard jobs, sweating away and coming home and complaining about their managers, right? And saying, oh, I got to finish this. There's a stand-up tomorrow. I got to report. And oh, it's crazy nonsense, right? And it's a pain. And I don't know how we started talking about that. And it's because many times people can't think things all the way through, and they say, I'm going to be doing this, dead end work, because I won't find out if it's dead end until I get to this place. But if you're good enough, you'll know before getting to that place, it's going to be dead end at that point, right? So you become a chess master, so you can know the outcome of certain moves before even thinking about them. And that is what knowledge in a field equips you with, I think. That is how musicians, I think, in my hypothesis, I think that is how extremely talented musicians, right, gifted musicians that I've seen, right, they are able to improvise incredibly captivating musical phrases on the spot, bam, like that, right? They're just sitting there in a concert, and then they're playing some in the middle of some intricate piece, and they just break off for like 15 seconds of improvisation, and they go into that contour and come back to the same point, right? So, and then you say, how could they have done that? Now, how could they possibly have done that if they had not been able to foresee that at the end of their improvisation track, they're going to be here? And there is no possible way I can see to get from there to here within that 1/8 of a time measure interval, right? Which I can play in my head because I'm, thinking about the melody. There's no way I can get there. So I'm never even going to try that improvisation track. But this person just, effortlessly, just bam, like that, does that. And I don't know if you've seen that, right? If you've seen these incredible concerts on YouTube, for example, and you see these people just do this. And the thing is, they don't even seem flustered. They just do that as part of their life, right? As if they were just doing that, right? As a spoonful of ice cream. And that is what extensive experience, knowledge, and repeated failures, right? Repeated failures, and someone like your, caring friend to push you even when you fail, saying doesn't matter, because failure, what you need to do is numb your brain, right? If you numb your brain to failure, it will not be a failure anymore. What people fail to do is they don't numb their brains. They numb their fingers, they numb their body to the failure, but they don't numb their brains. And therefore, their body gets tired. The brain gets tired and the body doesn't do it anymore. No, the right thing to do is just numb your brain, because it's going to be a failure, but you're still going to try it. That way, what happens is that your muscle memory builds. You know that you're never going to complete that 16 measure phrase, but you're still going to play. You're going to stutter at the third measure or something like that. You're going to try it. Keep trying it. Then you'll find tomorrow that you stutter at the 8th measure, not the 4th measure anymore, right? But you knew you're going to fail. You're not going to do 16 measures. You're going to fail at the 8th measure. You keep trying. Your day after tomorrow, 12th measure. But you got to keep doing that, right? So repeatedly in programming too, right? You're going to fail. It's not going to work today, right? So you give up hope that you will have it completed by the end of today, but you're going to try and keep solving one little thing at a time. Just one thing. If it doesn't work, that's fine, right? Let it be. But I'm not going to give it up forever. Come back later, right? I think that's a ticket. And many students, when they get frustrated, and make a note of this if you want, right? When you get frustrated in a problem, maybe not in the first few quests, but you will encounter this later, right? When you get frustrated, don't keep banging your head on a brick wall, right? I see that so many times amongst all the students, especially in 2A, right? So they, this is where we're going before, right? So they go down the wrong rabbit hole, and then and what we do is when we see a problem, initially, right, before, as kids, as programming kids anyway, right, when we see a problem, we are so clever as to think, oh, we know what the problem is, right? We know what the solution is. Now, most of the time, we don't know what the solution is. We think the rabbit hole is a solution, right? So we think, oh, that's the solution. I know, right? So we spend a lot of time and energy going down the wrong path. And I think, why did I start talking about that? Anyway, I think the way to do that is the way to solve these quests is to just get any programming problem, not just quests, right? And get to the place where you're stuck. Yeah, okay. And then don't keep banging your head on a brick wall. Just know that you're in a rabbit hole. Okay, get out of there. get out of there. So and most people don't get out of there. They just keep getting frustrated repeatedly in the darkness of the black rabbit hole until such time as they give it up for good. And that is what I don't want to happen to any of you guys, okay? Don't give it up for good. Because when you feel that you're going to get frustrated, you have to take a break, but it has got to be a break that is a measured break. You can't say, I'm going to take a break. I'll come back to it when I feel like it. Never works, okay? You got to say, I'll come back to it after 2 hours, 3 hours, 4 hours, whatever it is, even it's next day, that's fine, but make a time. You got to come back to it. If you don't come back to it, you won't get it, right? So you got to practice every day. Otherwise, you won't improve measure by measure. So, so keep that in mind. when you get frustrated and nobody's helping you, just come back to it later. Come back to it, right? But remember to take off, and that, I think that will. So let's try that this time, okay? Explicitly. I told that to students last quarter, but I don't know. If anyone actually got back and said that helped. But if it helps, let me know, because actually no, a couple of students actually did say it helped, right? Yeah. In fact, they made a post on Reddit saying it helped. I think Didier, yeah, he said, yeah, when you get stuck, you just basically just forget about it, go for a walk. Yeah, taking a walk actually does actually help, because you tend to think about something else, meaning you're out of the rabbit hole. You can see other rabbit holes, or maybe, right? And also the other thing to get familiar with is to develop the muscle memory of saying that the frustration is okay to feel. It's not going to kill you, right? Many times we are anxious and stressed out because we think the frustration is going to kill us. It's the end of the world. It's the end of the universe, right? Nothing is going to work in my life. My life is ruined because I failed CS2A. I'm not going to do this course well, right? So and that is a feeling that happens to creep up on students. Well, when I was a student, I used to have that feeling, right? For individual courses. But now, many years since I was a formal student like you, I feel that all that worry was misplaced, right? I wish I could go back in time and tell myself when I was like you guys, saying, hey, don't stress out. None of that is actually worth it anymore, right? So I wish someone had told me that at that time. But at the same time, it's good to feel that stress, because you need to feel the stress to be able to recognize that. Because if you don't recognize that, you won't know, right? Every time, because think about it, every time you see something that's unfamiliar, that's when you get anxiety. Right? If you know something that is predictable, certain, you don't feel stress, right? Because you worked it all out. And so reduce the unknowns and get out of there and feel the stress, and you know what it's like. You have to know what it's like to face a pointer error, right? Many students, look at the Reddit, will face pointer errors. Be vocal with your frustration. Complain on Reddit, saying I'm battling this pointer error for this long and I'm not able to find it, right? I'm close to giving up. Maybe someone can give me a hint. That's all fine, right? So, but you have to recognize what the feeling is, because I don't know, because unless if I want to hire a programmer or some designer who hasn't felt frustration, right? That is the most important part. You want to hire people who have felt frustrated in their lives, because unless you hire someone who's felt frustrated, how would they recognize when they run into frustrations later on that they're still alive after the frustration they felt a long time ago, right? So you need to be able to recognize that these frustrations are transient. And in order to do that, you need to face them again and again and come out and saying, okay, well, you know what, I had that 5 years ago, that had happened to me in my life and I'm still here, right? So you need to be able to say that repeatedly. And some of you are young enough not to be able to say that, but you have, as you face challenges head on, instead of running away from them, right? You'll know that these are just come and go, right? If you maintain your strong inner core and inner curiosity, right? That's the only thing that matters. You need to know in your life as a student, you just need to know how things work, how the world works. So you want to know, wow, it's a new skill. Oh, wow, if I go to this community college, I can find out these other people who have these skill and they are willing to teach it, right? So that's the purpose of community colleges in many countries, right? The equivalent of community colleges. The purpose is to basically let people who know things share that goodness with other people at very low cost. Think about it, right? Same course as this. If you do at UCSB, I'm sure a lot of UCSB students are my students in my CS2B, because it actually maps onto something they get credit for at UCSB. And how much are they paying? I don't know, $2,000 for, I don't know. Yeah, here you pay like $179 for in-state people, right? Even for out-state people, it's or even international students, it's not that much expensive compared to UCs. So you get all that for cheap, really. So you should take advantage of that and learn these skills. This is the only thing that you will find worthwhile, really, other things, but I'm not talking about the social aspects of things, right? So in terms of knowledge acquired, this is a time that you have the luxury of just learning while your other needs are being taken care of. Because what I find is that learning happens best when other needs are basically taken care of. And you have the freedom to say, okay, now you have 2 years of everything taken care of for you, and your only duty is to just go ahead and learn. That's all, everything you want. Just learn, because everything else I take care of, right? If someone said that to me, I would be like so grateful, right? Not me now, anyway, right? Because I know everything, right? But if someone had said that to me when I was a student, so it is one of the great things that can happen to a student, working student, right? Working student, because working students is really hard. Working moms, being students, really hard, because learning happens when you are 100% engaged, right? And things that get in the way, even little things that you have to make time for, they are very painful. You can do it. I know people who have done it, right? I know single moms who lived by themselves in Berkeley, who used to come to Foothill to learn, who now have graduated from Berkeley and doing really well. So they've done it, but they had to do it really hard. They have to, you can save yourself the hardship and say, I'll take advantage of the years when someone else is making sure that I can learn, right? But just be grateful to them instead, and use this opportunity, because learning is so precious, right? You don't get this opportunity later on, but you have to go looking for it. Now it comes to you, and you just lap it up. Or you can become faculty and you can learn for the rest of your life. All right, anyway, what time is it now? Holy cow, it's 9:20. It looks like I've been talking for almost 2 hours. You guys should just feel free to talk. Any other questions? We haven't spoken a single bit about data representation, right? Anybody has any questions on data representation?
I have a question. Can you hear me this time?
Yeah, Alex, now I can hear you.
Okay, thanks. So I was wondering, what's the benefit of using Tue's complement to represent negative numbers instead of just sign magnitude?
Very good question. Does everybody understand here? Because I don't know, maybe the audio is on. Everybody here heard what Alex said? If you wanted to know what is the advantage, why should we use Tue's complement? Why don't we use sign magnitude everywhere?
Should is related to a word with the following definition.
Oh, Alexa, stop. Oh, geez, Alexandria. All right. Well, I shouldn't call you Alex, because when I say Alex, she picks up. All right. What was I saying? Yeah, Tue's complement. Why do we use Tue's complement? Why don't we use so many reasons actually, but two of the strongest reasons, right? And you can find out more if you want. You can just Google. I'll tell you two reasons. One is, if you think about it, sign magnitude notation is not efficient. Is it efficient? No, because you use two bit patterns to represent 0. You have a total of 256 bit patterns. 2 of them represent 0. So there's redundancy. So there's something wrong, right? If you think about it from a mathematician point of view, there's something wrong with that notation, because you don't have a one-to-one map anymore. You got two things doing the same thing. It's not a function. It's not a function, right? 2 values of x giving the same value of y. So that's not the real reason, right? The real reason is because if you represent numbers in Tue's complement, you can do a lot of arithmetic operations really, really simply. Like addition and multiplication, addition, let's just do basic, just addition, right? Addition in Tue's complement works exactly the same as regular addition. You don't have to do any fancy jiggling of bits like you do. If it was sign magnitude notation, you got to do these funny things, right? In fact, if anyone can take the screen, we can work through an example right now. Let's do it in binary, in decimal first. We'll subtract one decimal number from another decimal number and see how we do the binary, carry and borrow and things like that. Things that we've been used to ever since we were kids. We can do that, and then we'll try and do something in binary, right? And then we can say this is by Tue's complement is one, and this is sign magnitude notation. This is the advantage. If I want to do this in sign magnitude notation, first of all, I have to convert that number. You have to turn that one minus, and then do this carry, borrow, and things. It's painful, and it's different. The algorithm meaning a sequence of steps you have to follow in order to get the difference of two numbers in a sign magnitude. The steps you have to follow different. Whereas in Tue's complement notation, you have certain advantages, saying that the same steps you follow for addition can also be used for subtraction. Exactly the same steps. So, I won't go into the details, because the details will take more time, and also it's a juice, right? You can discover these details yourself, and I'm happy to chime in. And by the way, right, even though it's only 2 lectures a week, if more than 5 of you more than 5 of you are interested in any damn topic, right? Doesn't even have to be computer science, I don't care, right? Hopefully related, right? Any topic, schedule a time, hopefully not some ungodly hour, right? Schedule a time, 20 minutes, 10 minutes, 1 hour even, I don't care, right? If I can make it, I'll just give a lecture. I'm just sitting here giving a lecture, I don't care, right? So I'll give a lecture anytime, any topic, right? If you feel that it's before the exam and you need a refresher on some concepts and the STEM center is closed, fine, right? Just reach out to me, 5 people at least, right? And let's set up a study room and I'll come and give you some problems to work on and watch over you as you solve and things like that, and I can help you, right? So let's make sure that thing is clear and you know that before we start. So yeah, so those are the advantages of using Tue's complement. Tue's complement is so easy, binary, bitwise, so that many algorithms are so much simpler and faster if you use Tue's complement rather than sign magnitude. So other than the obvious inefficiency of using sign magnitude notation, this is the reason why we use Tue's complement. Does it make sense? Okay. And obviously there's so many more reasons which you can discover. Just go to Wikipedia or somewhere, say Tue's complement, and then I'm pretty sure there must be a section in there, see advantages of Tue's complement notation, right? And you'll see there's like many different reasons, and you can summarize them, paraphrase them in your own words, maybe post them on Reddit and say, hey, data representation, I wondered and I asked in the lecture, in fact, in this video on YouTube, you can say, what is it? 1 hour and 25 minutes, 1:25, right? Under the video in comments, it'll automatically go to this place. When someone clicks on it, say, we discussed this and I looked it up, and here's the information I found on Wikipedia. So that's a nice, really nice post for you, right? On anyone, right? Multiple people can do that too if you want. So these are all things that you can queue off, find more information, share interesting things, right? So let's just make this class, Reddit also, right? Really interesting to participate, so that people actually look forward to waking up on Tuesday and Thursday, coming to class, having this interesting discussion, playing around together, right? Playing around together, coding up interesting things. We coded up a couple of really interesting things last quarter, I think. But hopefully, well, let's try the same things this quarter, because maybe I'll be able to talk through them faster. Because I think many of these are simple. I'll know which ones are really simple for students, so that those parts I can go faster, which means we can maybe try adding more frills to some of the things we did last quarter. We'll try. Okay. Well, I don't know. Maybe you guys will come up with better ideas we can try, right? Obviously, every single class, when we start coding, which will be like 2 classes from now, you should feel free to just propose ideas to code, right? If you don't say, let's code this, well, obviously you can't say, let's code a lander on rover, right? So we can't code. So there's got to be some level of complexity which we all decide we won't cross, okay? Because we only have 1 hour, 2 hours, maybe 1.5 hours to code most of the days. We'll say, you can come up with ideas, right? And if enough of us are interested, and I feel that it's simple enough and interesting enough to code in class, let's just do it, right? And in fact, it'll be good, right? Because then we won't have to go back to the same old ideas, because most of the time, I'll just pick up one of those old ideas if I can come up with one off the top of my head during class, right? And I'll say, okay, let's do that. And then I'll pick up an idea from a previous quarter. So if you can think up something, oh, well, tomorrow's class, we're going to be talking about methods and objects. So let's try and see, let's see if we can build a game using this, right? And you can propose that idea. And then we'll try and, maybe we'll whittle it down a little bit to make it simpler, fit within the 2 hours, and then we'll do it in class. So we can do all those things. And because if once we do that one time, maybe I'll do it one more time next quarter for other students, next quarter students, and then it'll be better than this quarter, right? Because now when we work through this, when I'll know the places where things needed to be speeded up, slowed down, and things like that. We'll do a much better showing next quarter, right? And then our inventory of problems we can pick and choose to code will start growing better and bigger. Right? Who knows? Maybe I'll even turn one of those problems into a quest, right? It'll be fun. And you say, oh, this quest is based on Fernando's idea from September 21st. Yeah, 1 minute and 1 minute and 29 seconds into the video, you'll hear Fernando and me talking about this video, this idea, which we turned into a quest. This is now quest number 4 on CS2B, right? So, or CS2A. So we can do all those really fun and cool things. Yeah, anything else? I'll try and be, briefer. We got time. Or any of you can pick up the screen too. Pick up the screen and share a tablet with a pencil, right? And then we can work through some problems. I think that'll be interesting. Or if you find there's a part in the module, any module, right? Well, right now we're only doing data representation. So if that is confusing, you can just basically share your screen and show that module and say, can you explain that in different words? Better. I can do that too. So many different things we can do, right? In class. Go on. Anybody can talk. If you want me to step away so that you can have a free conversation amongst yourself, I think that helped last quarter. I took off for 5 or 10 minutes so that you guys can just talk amongst yourself. Is that okay? Do you guys would like to do that? We're not having, by the way, at Foothill, we're supposed to have this 5-minute break between 2 1-hour sessions, because these are 2-hour classes, right? 1 hour and 15 minutes. We're supposed to have this 5-minute break. We haven't been having it in my classes anyway, because I think programming is different from other classes. Because you have classes with physical activity, even writing things down. You need a break. Programming, if you're on a roll, you should be on a roll, right? Because landing to a stop and then picking up acceleration after that is more painful in programming. So I figure in programming, just keep going. If you need to take a break, just go inconspicuously and come back without disturbing others. That's perfectly fine. Nobody really cares. All we need is for you to be here. Still, many of you don't have your cameras on, right? Now I can see your names, but you should strive. You should strive to keep your cameras on during class. Okay, it doesn't matter. Yeah, we have to get into a community of non-judgmental folks, right? We don't care about anything, right? All we need to care about is whether the stuff is interesting and we can do cool shit with it, right? We need to be able to do really cool things. Cool meaning we can do something that really makes us happy, right? Fun things that we always want to do. That's what we want to do. So don't worry about anything else. And that's the only thing we need to be able to pick up. And nothing else really matters. Even in life, you'll find most of those other things really superficial. It's a waste of time, right? This kind of thing will really give you deep satisfaction. It will stay with you forever. Just pick up the skills. I tell you, right? And I can teach you. I can teach you every little detail I know. I'm happy to teach, right? Because everything is so wonderful. It's so yeah, awesome. All right. Any other questions in data representation? Because only 2 classes. Remember, only 2 classes talking about data representation. After next week, we'll start programming. When we start programming, you look at the lectures from last quarter, right? We don't get a chance to talk about these data representation issues, right? So maybe we'll mention in passing, oh, that's why this has got to be unsigned, right? Not signed. But many people get bitten, even in 2B. Look at the subreddit for CS2B, right? Many students who didn't do my CS2A, right, came to CS2B through a waiver, and they get bitten by that bug. And they say, I have a loop that never terminates. And because they used a signed unsigned comparison or something like that. And they ignored a warning. So those are things that data representation will make sure you don't make. It's really I don't know if you guys feel it, but it is really not pleasant to get a basic bug when you're working on something at high speed, right? When you're working on something really fast, right, and doing something like that, bam, 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 like that, and you're off by a semitone or something like that, it really sounds jarring. And it doesn't sound so bad when you're practicing or in CS2A, but it will be bad later on, right? Because you may think that, I think the reason it's bad is because you don't expect it. When you get really good and when you're going fast, you don't expect yourself to make silly mistakes. Yes or no? That is the only reason you go fast. The reason you're able to go fast is because you don't have to be on your guard looking for silly mistakes, right? If you're looking out for silly mistakes every time, you can go fast. So you're going at 2 miles per hour. But when you go fast, you have the luxury you know things enough to be able to trust that the mechanics, the physics of the world, science, science will rule. So you'll know that these things will work as predicted. So I don't have to worry about that. So you can go fast. So imagine when you're going fast, if something does not work as predicted, okay, then you're really in, it creates bigger accidents, right? Because two things, right? First of all, you don't expect it, so you don't even see it happening. Second, because you are now expecting problems at a higher level, right? That is worse. Not expecting, not seeing, okay, all right, that even now you encounter, right? Worst thing that will happen, which is not happening right now. Remember, it is not happening right now, but you will see it that is really bad. You will expect something bad to happen somewhere else, which you don't right now. And you have to be like super duper thankful you don't, right? Because we are so good, then when we suspect something is wrong, even though it is wrong, right? We'll actually go down it. We'll think that is a real reason. That's not a real reason, because when we're so sure, and we'll spend lots and lots of time going down the wrong rabbit hole, because especially when you're going fast, there are so many things that could go wrong that you will think that they are going wrong, and you'll go after them when it was really something so simple that you would have fixed, that would have saved you 5 days of effort. Go to the CS2C subreddit, okay? In fact, with 5 minutes of searching, I can find a post that'll say that so many students have posted, say, I have wasted 1 entire week trying to solve this problem. 1 entire week of frustration. I was ready to give up computer science, and I found this was simple constructor bug, right? Which I should have fixed on day 1. And people say that, and many people have said that, and imagine what kind of frustration, right? 1 week of banging your head on a wall. Maybe you don't feel it now, right? But you can save yourself. You can save yourself all that pain by just, doing blindly, right? Just taking my word for it and mastering it. You need to know the ins and outs on data, right? Once you know, then you won't make these silly mistakes. Then when you make the big mistakes, it will really be a big mistake, right? The problem with human life, I think, is when small mistakes masquerade as big mistakes. And then we try and fix these big mistakes, which are not even mistakes, right? Because of a small mistake, which could have been fixed. And that happens all the time in programming if we're not careful. And that is why learning to be careful programmers is important, more important than being clever programmers. And that is why when you're early in programming, it is important to go slow, not fast. Many students in CS2A try to go fast, right? Bam, 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 right? No, that is not the way to master anything, right? So when I used to take my daughter to piano classes, in the beginning, she used to play everything fast and all wrong too, right? And then the teacher said no. So if you play things wrong and fast, you'll just play wrong and fast, right? So you got to play it right and slow. But if you play it right and slow repeatedly, then it'll be right and fast. But if you play wrong and fast, it'll get faster and wrong and faster, right? So you got to, the only way to get right and fast is to start right and slow. And many people want to go right and fast immediately. No, it doesn't work, right? Fast goes with wrong first, right? So go with right, go with slow, and then take right with you to fast. If you go to fast, you'll get wrong. So that's the way to do it. Okay. So data representation, super duper important. You only get 1 week, okay? And don't be misled by saying 2 lectures, okay? Today and Thursday. No, you have 1 week, 7 days. Until next Monday, you should forget about programming. Just get solid on data representation, right? Just master all those 12 pages or 20 pages or whatever it is in module 0, such long time since I read, right? Just be solid on that. You'll really find, all right? And I'll be surprised if you don't make a Reddit post later on saying, wow, I mean, if I hadn't mastered data representation, I would have spent so much time on that, right? Or, this is why your program is failing. It's because of this, which is because this is signed and that is not signed, or this is, 2 bytes and that is 4 bytes. All these things, so important. And the thing is, also, lots of people think that, oh, there's so much material, and, I got to learn this and that and that and 2B and 2. But the thing is, all of this this much. It seems intimidating because it's this much. But the thing is, and tell me if I'm wrong, right? After you mastered all of this, it does not remain this much. After you mastered all of that basically just vaporizes. It's not this much anymore. It's zero. Because it's not possibly part of your conscious knowledge anymore, right? It becomes subconscious, muscle memory, brain muscle memory, maybe, I don't know, right? So it does not, so the amount, the magnitude of information that you need to store never gets intimidating, right? Doesn't keep getting bigger and bigger, right? It'll always just say, if you think that, oh my gosh, there's so much in CS2A and there's so much in CS2B, so much, I got to do all that. No, it's always only this much, right? Provided you master this much, you'll be starting CS2B again, only requiring to master that much. Okay, lots of people don't know that. Many students don't. Ask your classmates, right? Outside of class, ask your classmates. Many classmates don't know. They think that at the end of their 4-year university class degree, they need to know that much, and they only know this much. Oh, I got to learn that much. No, any given day, you only need to learn a finite amount. And the only people who actually learn that much are people who have drilled into their heads, make it a mantra and telling themselves 10 times every day, right? No matter how big the sea is, I only need to take 10 steps today, right? So you got to keep telling yourself that repeatedly. Otherwise, you'll never take those 10 steps, right? Because you'll see, San Francisco is so far away. I'm never going to reach that on foot, right? So you'll never start. And if you never start, you're never going to try. And if you never try, you're never going to succeed. So I think the way to succeed here is to just say, well, okay, well, right now it doesn't look like I'm going to be able to craft, Fortnite on my own, but I'm going to do it. I'm going to do it anyway, because today I'll learn about data representation. Maybe tomorrow I'll learn a little bit about C++. Okay, in 6 weeks I'll learn about classes, methods. Well, and then maybe in about 5 months' time, I'll start to learn about many classes and algorithms, putting them together, and I'll learn it's really problematic. I'm just doing the same thing in these classes over and over again. How easy it'll be if I can just draw these things on a piece of paper and say, well, I don't want to do this entire class, but it's the same code over and over again. I'll just draw it on a piece of paper and I'll give it to this person, and that's a machine that can do it for me automatically. Yes, right? That is a visual programming language, right? And then you'll say, okay, I'm going to write these classes, but I'm going to use a sermon. I'm going to draw these pictures, and I give these pictures to the sermon, and they'll do the classes for me, right? And Unreal, for example, or Unity, or all these, modern programming frameworks, they give you the framework. They give you a visual scripting language. They say, you want to write a program, and you're going to be doing the same classes over and over again. Okay, well, you know what? I'll give you all these classes as pictures. Draw these pictures and pull these pictures in and just connect them with lines. I'll do the needful for you, right? Already in many of these IDEs that you do, right? So these things like getters and setters, you can just right click. I'll show you, right? In just a couple of classes, you right click and say, oh, generate all the setters and getters. Bam, boing. Right? You got like 50 to 60 lines of code automatically generated for you, right? So let's just take it to the next level. And this is modern programming paradigms, and say, well, I want this to happen. I want a replication to happen between all these players right now, and this to react like that. Okay, connect all these lines and then click a button, and bam, it'll just translate all of that into C++ code for you. And also, they do a really nice job these days, right? It's not even translated into obfuscated, unreadable C++ code. It's actually translated to readable C++ code that after it's translated the visual thing into C++, you can actually go into C++ and understand everything and change things, change in parameters, all this. See, the thing is, a lot of these amazing tools that you see out there that you'll encounter, they're also built by programmers like you, right? That's the beauty of it, right? So because it's like you take music, it's music, lots of things are pleasing, but we're not musicians like them. Well, many people aren't, right? So whereas programs, you'll see that lots of these amazing things that you use are actually built by programmers, right? And therefore they know the pain points. They know all the pain points, right? That is why it's important that you learn all the pain points, right? Don't enroll in my class hoping that you will not encounter pain points, right? Because not encountering pain points, you have everything else. You have your parents, you have your friends, you have your society, you have your social life. All of those are good places which will give you non-pain points, right? Positive feedback, lots of adrenaline and all these things. But in any class, really, you should go saying, well, I'm getting all my fill of pleasure from everywhere else, but that's not life. I need to know all the pain points also, so I can navigate around them, right? So you need to be able to navigate around them, because between the pain is where you'll find the greatest of pleasures sometimes. But you'll never get there if you're trying to avoid them wholesale, right? So you need to go into the fine detail, fine cracks, right? So that's why you can craft these masterpieces. So you need to be able to not be afraid of them enough to be able to approach them and say, well, you know, what's the worst that can happen? So I know enough to maneuver so that that doesn't happen to me. So it's jiggle in and say, well, I can do these incredible things. And yeah, those kinds of things will become possible, I think, with C++. You know, all these other languages, any advanced frameworks you can use, you will know to use. You talk about, you know, if you talk to random people who are using these advanced frameworks, many of them don't even know what's going on, right? They say connect up these boxes and eventually you get this magical game, right? First-person shooter or things like that. But they don't know how they got it. They just say this is boxes and these things flowing between the boxes. But when you see those boxes, you don't see boxes, right? You just see classes, you see messages passing. You see the individual bits and bytes. And in fact, if you are patient enough, you can actually see the individual electrons and how switches turn on and off, right? You can see them, right? If you slow yourself down, right? Except that the switches are turning themselves on and off so fast, you can't really see them. But you can, if you slow your mind down to that speed, you can actually see that's exactly what's going on. No magic there, right? So you will feel a lot more comfortable. So when you go to an interview, right? When you go to an interview later on, and they say, oh, you know this, can you architect it on a whiteboard, right? So you design this product or you code on a whiteboard, you won't feel anxiety or stress because you know, right? You know what's going to happen if you do that. So you won't even try that, right? So no stress, no anxiety. You say, oh, you know what, let's try that. Gee, no, that's not a bad idea. Let's scratch it out. Do this. All of that is fun. Fun not only for you, also for the interviewer. Those are the kinds of things that interviewers are looking for, right? So when I interview someone, I'm not looking for someone who just basically just go and knock out a solution. Bam, 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 bam. Okay, well, he's a minimum spanning tree like that. Okay, wow. Okay, well, I can open a textbook. I can have the algorithm right there. So what I'm looking for is basically someone who can basically run into some interesting problems, right? While they're doing that, because there's someone who's familiar with that, who's done that like 5 or 10 years ago in school, right? Understood that, but hasn't coded that since then. So those are the kinds of problems the interviewers want to pick, right? Interviewers want to pick problems that have interesting algorithmic solutions, which you may not have, which you know how to solve in grad school, right? But you have not really encountered so far in the last 2 or 3 years. Right? We want to pick those problems because those are the ones for which you know the solution, right? Because there's no fun. As an interviewer, there is no fun giving you a problem for which you don't know the solution. I can tell you that right now, right? That is the whole reason why we have phone screens, right? The reason we have phone screens, and people think a phone screen is a way in which to, well, it has 2 purposes, right? It also weeds out people that, right, won't be a fit, but also it selects candidates that will guarantee that it will be fun for both parties, right? It's fun for only one of 2 people. It's no fun really, right? Pretty soon it'll stop being fun for the other person too, right? It's got to be fun for everybody involved. Otherwise, it's no fun. So the purpose of the phone screen is to basically identify if you're a curious scientific sort of person who kind of asks questions, gets stuck at the right kind of places, right? You got to get stuck. You got to get stuck at the right places, right? There's lots of places to get stuck, but which places are you getting stuck in, right? But don't get stressed out over it. You just have to feel curious and comfortable with it. You get stuck in many places on your own, right? And then you'll know, right? So, and as an interviewer, they want you to get stuck at these places so that you can now say, my God, I don't know what to do there. Let's see. Maybe I can use a hash table. Gee, no, that's too much. That'd be too heavy. Okay, let's try a priority queue. All right, let's do a priority queue. All right, so you try, right? You try these data structures, you try these things, but right? And then when you try that and you say, you put it there and say, wow, okay, well, a long time ago, you know what, in CS2C, I did that problem and I actually did use a priority queue, right? So you know that, bam, like that. And those are the kinds of things that people are looking for, not just interviewers, right? Even people that work with together. Sometimes you may have solved the same problem in grad school together, right? But you have forgotten steps B, C, D, right? That person has forgotten steps, I, J, K, right? And you come together to solve the problem, and then they're actually expecting, right? So I know how to solve these, and this person knows to solve those, and then you together build a solution, right? So those are the kinds of fun things you can encounter. And in order to do that, of course, you need to encounter as many different problems as possible. and be frustrated, go back and come. And so that's what I do. So the one thing I did with Peter before, right? So it's a squirrel last quarter, right? Now it's different, right? So Peter doesn't come by anymore. This is 2 young squirrels. Now this one's bigger. He's quite tame. But that guy, I used to give him peanuts, right? I used to give him peanuts. And then I got into the habit. He liked peanuts, right? He liked peanuts more than everything else. Acorns, acorns he likes most, right? So I used to give him a lot of peanuts, and then I used to give him a lot of peanuts. He never, he never ate them all here. He would basically stuff his mouth with as many peanuts as he could, and he would go away. And then he'd sit on a tree branch somewhere and eat them. And never got tame for a long time, right? Never got tame. So I thought about that. I figured, well, it's basically, I'm giving him positive reasons. In machine learning, we call them positive examples and negative examples, right? So positive example is when you see a behavior that you like, you need to reinforce that, right? You have that happen again and again so that it reinforces. But you have to create opportunities for that to happen again and again, right? You can't just force him to come, right? So I said, well, you know what? I can't. So that didn't happen. Every time I give him a handful of nuts, just go away. So I figured the best way to do this, I'm not going to give him a handful anymore. Let's give him 1 nut at a time, right? So I'd give him 1 nut and then go away, and he'd eat it. And then he'd wait and he'd come back for me to give another nut. So that just increased the number of opportunities like 20-fold for me to give him nuts, which means that instead of 1 positive example, I was getting 10 positive examples to his brain. This neural net, 10. Each time I had a handful of nuts, I was giving him 10 positive examples. So very soon he became tame, right? In a couple of weeks, he just became tame. He just come here, sit down. He just come here. Sometimes one time he was actually almost came inside when I was a lecture, right? And his students had a good time, I think. So yeah. So I think that is the key to it, is to basically force yourself to face the same situation repeatedly, right? It'll feel a little painful initially, but put yourself in it again. But it was painful last time, so I know how much pain it's going to be. So I'll just take some basic precautions. If I get too close, I'll try and back out, and so on and so forth, so on, right? So even social situations too, right? So keep trying that repeatedly. Put yourself in the same place one more again and again. Not too deep, not right. But the idea is to get familiar. Familiarity breeds inureness or inurity. I don't know how do what's that? I don't know what the noun form of. Makes you inure, right? So so that's what's going to happen. So you can be sure not to. So yeah, so that is in 2A. What I have in the Bay Area, I don't know if it's nationwide. In the Bay Area, in the past, in schools anyway, many students tended to get an incorrect idea built into them of this feeling of being entitled to everything, all answers, right? So so nobody ever comes to class with an expectation to work to get answers. They say, I have a bunch of questions and I ask and I get answers. For exams, I just memorize things and so on, right? So that's because they're entitled, right? So then, and I think that it's bad because it prevents you from really enjoying it or appreciating or even learning from it. Because if you just get an iPad, when the iPad comes out, I'll just get an iPad, right? So if the iPad doesn't come out, you just get disappointed. You're not happy, right? Whereas if the iPad was a pleasant surprise for you, you're happy, right? So you can turn it into a reward instead of a disappointment by taking it for granted. Yeah.
Hey, Anna, this is Agnes again. Sorry, I have a meeting. I have a customer meeting at 10, and I was hoping that it would be okay if I just dropped.
Totally. I think I'll let you all go, by the way. Thank you all so much for coming by and listening to my, all this nonsense. Are you guys coming back on Tuesday, by the way? Right?
Thursday?
Oh, Thursday. All right. All right. Thursday. Day after tomorrow.
And we are,
it
is the same link?
Same, no, not the same, next one. Yeah, I think there's a different one.
Okay, I'll post. Thank you so much.
This is the date. Yeah, come back on Thursday. We'll have a chat. Thank you so much. Thank you all for coming. I hope you enjoyed the lecture.
Thank you.
We'll talk about data representation. All right, come with questions. Come with questions. Someone share a screen, or I'll share my screen. Okay, we'll work through some data representation problems. Right, we'll take some problems, work through them. Next week start coding. This week only data representation. Don't code. Data representation. All right, thank you so much.
Thank
See
you.
you soon.
Bye.
Bye.
Thank you, Ann. Bye.
Bye.